everyone, my name is Osama and today we're going to talk about my project for ME3613. The project for today is going to be a self-watering system. Let's get right into it. The agenda for this presentation is going to be as follows. First, I'm going to touch on the importance of the system and industry. Then I'm going to move on the equipment. Next, I'm going to show a simplified diagram to illustrate how every part is connected. Finally, I'm going to show the project working in action. So let's first talk about the importance of such project in real-life application. This project can be used in any system that requires a steady level of moisture. So our creativity is the limit in this case. However, this system is most commonly used in the agricultural industry. Before this method was invented, farmers, especially in dry environments, had to work many hours to ensure their crops don't get dry and die. But this system is able to detect when the soil gets dry and send information to the water pump to start watering automatically. This method is used all around the world nowadays, since it has been proven to be much more economical than the traditional means. Right, so what you can see behind me in the screen is the required equipment to have the system up and running. So as you can see here, we do have the microcontroller, the capacitive soil moisture, the relay, the power supply, the breadboard, and a water pump motor with the tubing connected right to it. So the slide behind me shows a simplified diagram of the entire system. So the rectangles represent the components and the black lines represent the wire connections. As you can see here, the breadboard is acting as the main core component. It is connected to the capacitive moisture sensor, which is submerged inside the soil. The readings collected from the sensor is converted to voltage data via Arduino Uno microcontroller and sent to the computer to be plotted using MATLAB. The microcontroller is connected to the computer using a special USB port. The microcontroller also gives commands to the relay to turn on the DC motor water pump. The water pump motor is powered using a power supply connected to the electricity. The water pump motor has to be submerged in a container full of water so it can collect water and forces it through the tube into the soil. So the microcontroller can be set to turn on the water pump via relay whenever the capacitive moisture sensor gives a reading that indicates that the soil is dry. And that's how the system works in a nutshell. Right here, I'd like to show what I described in the previous slide in practice. So first of all, we have the breadboard here with the microcontroller connected to the computer. MATLAB is open and ready to go, and the Arduino support package is installed. The board is also connected to the moisture sensor dug here inside the soil, and lastly the board is connected to the relay, which is connected to the power supply. It is connected to the water pump inside the water container. So I'm going to run the code now. So as you can see, this plot is showing the voltage reading coming from the moisture sensor, and it's showing a voltage of 1.96. That's the voltage coming from inside the soil. Looking at this restriction that we put here, 1.8, the pump should start watering the soil if the power supply was connected. So let's see if this will work now. So this is starting to turn on, and this here is water in the cup. It's supposed to be here, and it will stop whenever this is wet. It stopped automatically when it was wet. And as we can see here, the graph, the voltage drops significantly, because the more moist it is, the less voltage the reading will show. So I try to summarize before ending this presentation. So this project represents a very common system that is used primarily in the agricultural industry. This method was proven to significantly decrease cost. The most critical tools of this project were discussed. The system functionality was demonstrated in theory and in practice, and every connection between each component was shown with the use of a simplified diagram. The MATLAB code was shown along with the voltage plots. I would like to thank you for your attention, and if you have any questions, I'd be very happy to answer via email. Thank you again for listening, and I hope you enjoyed the presentation.